This is my creation work area where I make videos like the metal models and Lego. In this setup I use 6 LED lights and they are all connected to a 6-port USB charger. Something I've noticed is that after a few minutes these lights dim automatically. After much research I've come to the conclusion that the USB port charger is thermal limited. I've checked the LED lights and they specify 5 volts 2 amps. The USB charger specifies each USB output is 2.4 amps max and the overall output of the charger is 12 amps. So my 6 by 2 amp lights do not exceed the 12 amp max output of the supply, and each port is rated to 2.4 amps but each light is only 2 amps. I originally started out only using 3 LED lights and it took a while before the lights dimmed. I thought that the lights were getting too hot, so I added more and reduced the output levels on the lights, but they all dimmed much quicker. At this point I assumed it must be the charger that has a thermal limiter in it. Once it hits a certain temperature it drops the output. This was a good reason for me to buy a thermal camera. Well, I really wanted a FLIR, and you can get one that plugs into my iPhone. That costs like $600 and that's way too much money for a bit of fun. I did however search YouTube and found people making some basic ones. So I searched eBay for the sensor they use in the videos and found an all-in-one unit with display for $100, which was only $40 more than just the sensor. So it seemed like a no-brainer just to buy the all-in-one. Here you can see the USB charger while it's plugged in, but none of the lights are turned on. Its resting temperature is 27 degrees Celsius. I then turned the lights on and walked away, and when I came back 40 minutes later, the temperature of the charger was now 59 degrees. I was a bit curious and thought there must be a heatsink inside that I could attach a bigger heatsink to and perhaps dissipate the heat over a larger surface area and prevent thermal throttling. So I went about cutting it open to investigate how it was made and seeing what I could do. This took a bit of fiddling around, but eventually I got it out. Once it was out, I could see that it had 2 separate aluminium plates inside. Perhaps I could attach a bigger heatsink to these. But I first decided it was best to power it back on and use a thermal camera to pinpoint where the heat is coming from. I could clearly see it was getting hotter in one section, but I couldn't tell if it was coming from the transistor or another component. So I moved the USB port being used to one further away from the transistor. It didn't take long to see the heat signature was coming from the surface mount components relative to each USB port and not the large aluminium plate. At this point it's clear that my idea of adding a bigger heatsink isn't possible. The design of the electronics is not that simple. I need to find another solution. Probably just buying 6 individual chargers will be the answer. What I am glad about is the purchase of the thermal camera. If I didn't have it, I would have probably gone ahead and added a bigger heatsink, wasted a bunch of time, and wonder why it didn't work. By being able to pinpoint where the heat was coming from, I was able to make an informed decision that saved me time and frustration. That's it for this video. Not a positive outcome in the end, however I do like showing when things don't work out as planned. It's all part of trying ideas out. Let me know your thoughts in the comments below, and until next time, bye.